Okay, today we are doing lesson 7.4 called Linear Inequalities in Two Variables. We will be graphing linear inequalities. Linear inequalities are simply the equations that we've been doing with x and y. The equations are now going to be inequalities. So we're going to have less than, greater than, less than or equal to, or finally greater than or equal to. We're going to be finding solutions. Solutions are the same for an inequality as they were for an equation. Solutions of an inequality are any ordered pair x, y that makes the inequality true. So just a brief preview. This would have been a linear equation. And now this is going to be the graph of a linear inequality down here. So all of these shaded coordinates are solutions to this inequality. So let's go ahead and get started and talk through this very first example. It says graph the solution set for 2x minus 3y is greater than or equal to 6. There are two variables. We're going to solve. Step number 1 is to solve the inequality for the y, just like we did when we were doing equations. So off over here on the side, I'm just going to do a little solution as well. I know that they've done the same exact thing for us already. So 2x minus 3y is greater than or equal to 6. I want to isolate that y. It's in this term, so I'm going to do the reverse order of operations and move my 2x. So I get left with negative 3y is greater than or equal to negative 2x plus 6. And I continue, divide all terms by negative 3. So I am left with y, and over here, negative divided by negative is a positive. Now, we haven't done this for a while, but last year, when we divide by a negative number, it reverses the inequality symbol. So it used to be it's greater than or equal to, and it now is reversed to less than or equal to. This happens when we divide through by a negative, or also when we multiply through by a negative. So this is our inequality solved for y. We use this solution to graph what we call a boundary line. Now down here, put a star down here, it says consider the line where the inequality is replaced by an equal sign. So instead of our inequality symbol right here, we've replaced it with an equal sign. This is known as the boundary line. Now the boundary line is solid if it's a greater than or equal or less than or equal due to the equal part, because it could be on the line. A solution would be on the line. This boundary line would be dashed if it was just a simple greater than or less than, because the solutions do not include what would be equal to the line. So what they've done here so far is they've graphed a solid line. On the next page we'll get into what a dashed line would look like, but you can imagine it's just a broken up line. So the step 1 was solve the inequality for y. And now step 2, we're going to use that boundary line to graph what we know about equations. So we're going to graph the boundary line. So for this one, we're going to go to our y-intercept of negative 2. And on this graph, they've counted by 2s. So negative 2, negative 4, negative 6, negative 8, negative 10. So we're going to start here, and we're going to count our slope. Our slope is 2 over 3. So we're going to go up 2, which is only one box, and we're going to go over 3. And again, each grid line is worth 2. So in between these two grid lines, this would be 2, 4, 6, 8. Again, we don't need to label all of them. So we'd go up 2 over 3, up 2 over 3, up 2 over 3. Similarly, we could go down 2, backwards 3, down 2, backwards 3. And you can see that this would be our boundary line. And I'm making it solid because it was or equal to. Okay, so now our third step is to shade the appropriate part of the graph. Now, some people just do this right away. I have always just moved on straight to step 4 for my graphing, but excuse me, you can use the symbol's direction to figure out which way you need to shade, either the top half plane or the bottom half plane. So what they've done is they've said, if the y value is less than or equal to, so the y values are less than when they are lower on the y-axis. So because our symbol is oriented so the y values are less than our answer here, they've gone ahead and they've shaded this whole direction. Okay? So we shaded below if it was a less than, or we would also shade below if it was just a plain less than symbol. Okay, on the next page we're going to shade above, and you'll see it's for the other direction. If it's y is greater than or equal to, you would shade above your boundary line, or again, if your y value was greater than, without the less than equals symbol, you would shade above. So you can go ahead and use step 3 right here and just shade the appropriate part, and use step 4 as a check. So step 4 is to check your work. Choose 1 point above the line and 1 point below the line. We're going to substitute those values in and check for the truth, the validity of the statement. Let me turn the page and I will show you what I'm talking about. So what they've done here on the top of the next page is they chose 0.00 and 0.0 negative 4. So 0, 0 is clearly above the line in our graph, and 0, negative 4 is clearly below the line. Let me just flip back really quickly so you can see what that means. So they chose this point right here, 0, 0, that I just circled. It's clearly above my boundary line. And then they chose 0, negative 4, which is 0, negative 4, which is clearly below the line. And they're going to check for the truth or the validity of the statement when they plug it into the equation. So when they plug in 0, 0 to our equation, they plugged in 2 times the x value 0 minus 3 times the y value, which is 0. Is it greater than or equal to 6? So when you do this problem, you get 0 minus 0. Is 0 greater than or equal to 6? No, 0 is not greater than or equal to 6. So that means that that side, that half plane of our coordinate graph is not a solution. They are not solutions. When they plug in negative 4 to the equation, which is clearly below the line, they do 2 times 0, that's the x value, minus 3 times negative 4, the y value. They get negative 3 times negative 4 is 12. Is 0 plus 12, is 12 greater than or equal to 6? Yes, 12 is greater than 6. So that is true. So that point is true. So they've shaded below the line. Let's just do a little bit of reflection for that one. The set of solutions to an inequality is represented on a graph by a shaded region and a boundary line. This area is called a half plane. Why is a half plane a good name for this region? So a half plane represents the half of the coordinate of the whole coordinate plane. Okay, so either everything above a line or everything below the line. All right, so let's do the your turn number 2, following our steps. So your turn number 2, following our steps. First, we're going to solve for y to find a boundary line. So if we go on here and we solve for y, subtract 4x from both sides, you're left with negative 8y is greater than or equal to negative 4x plus 32. Going to divide everything by negative 8. Again, we divided through by a negative, so it's going to switch our sign. Our sign used to say greater than or equal to. It is now going to say less than or equal to. So we're left with y is a negative 4 divided by a negative 8 leaves us with 1/2. 32 divided by negative 8 leaves us with negative 4. So this is our step 1. We've solved for y. Now we're going to graph. We're going to graph our boundary line. We're going to start at negative 4. Again, they're counting by 2s. And we're going to go up 1 over 1, up 1 over 1. So they are counting by 2s. So we're going to go, up 1 over 2. We're going to go up 1, which is half of a grid, and over 2, up 1 over 2, 1 over 2. Okay? Similarly, we go down 1 over 2, down 1 over 2, down 1 over 2. Okay? So we connect these points. I'm making it a solid line because of the equal part of the inequality, that little equal part. So that's step 2. Step 3 is to shade the half plane. Now I know that the y values are less than my line, so I'm going to shade down the lower half, but I'm going to skip to my step 4, which is check 1 point above and 1 point below. A very easy point to check is always 0, 0 if it's clearly above or below. And then I'm going to go ahead and I'm going to check this one, which is clearly below. So if I plug the point 0, 0 into my equation, 4 times 0 minus 8 times 0 is less than or equal to 32. Is 0 greater than or equal to 32? No, it's not. So that means that this side with this point is not shaded. So this side, this half plane, is not shaded. Let me just double check and make sure that my second point, 0, negative 10, does make my inequality true. So I would plug it in. 4 times 0 minus 8 times negative 10. Is that in fact greater than or equal to 32? So I get 0. Negative 8, negative 10 gives me a positive 80. So is 80 greater than or equal to 32? Yes, that is true. So that means that this is true. So either way I solve it, it's the bottom half plane that is shaded. All right, let's move on. Example number 2, graph the solution set for the inequality 26 plus 2y is greater than 14x. So the difference here is this is an inequality symbol, but it does not include the or equal part down here. So notice, looking ahead and cheating, we look at their graph, and that boundary line is not solid, it is dashed. Because any of those numbers that I plug into this statement are going to be false. So let me just choose one of these points and see if we can make sense of that. I choose the point 0, negative 13. 0, negative 13. I would be choosing my y-intercept. Okay, they've gone through and they've done step 1 for us. They've solved for y. This is our boundary line equation. It's an inequality, but we're going to graph it as an equation. So if we graphed this, this line would continue all the way down, okay? And it would cross at 0, negative 13. If I plug those points into my equation up here, so I'm plugging in the point 0, negative 13. If I plug this point in, I would get 26 minus 26 is greater than 0. Is 0 greater than 0? So I plugged it in, 0, negative 13, to my original equation. 26 plus 2y is greater than 14x. When I plugged it in, I got 0 is greater than 0. 0 is not greater than 0. So that's where the boundary lines dashed form comes in. There's no equal sign down here. So this is just the boundary line separating my half-plane answers. So once I graph this, I would graph my points. Let me go over here. They've graphed it for us. And now they've solved the y here. So they've shaded the above part of our coordinate plane because the y values are greater than 7x minus 13. So above the line. Again, this is not how I've always solved them, but this totally works. I would skip to step 4, and I would choose a point that is obviously on one side of my line, above it, and I would choose a point that is obviously below my line, over here. They've chosen the same numbers down here. So when you plug these into the original equation, we have 26 plus 2 times 0 is greater than 14 times 0. Is 26 greater than 0? Yes, 26 is greater than 0. So when I plug in 0, 0, this is true. It makes my statement true. So I'm going to shade this direction. If I plug in 4, 0, I would get 26 plus 2 times 0 is greater than 14 times 4. Is 26 greater than 56? No, 26 is not greater than 56. That means that this half plane is left unshaded. Okay, let's do this reflection question. For the linear inequality 6x minus 3y is less than 24, which of the following is a solution? You're going to substitute this point in for the x and the y and see if your statement is true. So over here on the side, I'm going to plug in 0, negative 9. 6 times 0 minus 3 times negative 9 is less than 24. Is 0 plus 27 less than 24? Is 27 less than 24? No. So 0, negative 9 is not a solution. When I plug in 6, 4 to my same equation, 6 times 6 minus 3 times 4 is less than 24. Is 36 minus 12 less than 24? 36 minus 12 would give me 24. Is 24 less than 24? No, it's not less than 24. That would be part of my boundary line. My last one I'm going to check is 4, 1. When I plug that into the same equation, 6 times 4 minus 3 times 1 is less than 24. 24 minus 3 is less than 24. Is 21 less than 24? Yes. So 4, 1 is a solution to my inequality. Okay. Number 4, is 4, 0 a solution for the inequality 6x minus 3y is less than 24? Explain. Let's check. 6 times 4 minus 3 times 0 is less than 24. Okay, I could have just pointed to our work before. So this is not a solution because it's an inequality symbol that is a less than, not a less than or equal to. So an explanation would be 4, 0 lies on the boundary line, but it is dashed due to the less than, not less than or equal to symbol. Okay, so we're going to skip over this your turn. Graph 6x plus 3y is less than negative 12 and move on to a real life situation where Francesca can spend at most $6.75 on healthy snacks for a party. Veggie chips cost $1 per package and grapes cost 75 cents per bunch. Find 2 combinations of veggie chips and grapes that Francesca can buy. So first of all, we need to think about what this is. They've already done a beautiful picture for us. Veggie chips and grapes. So veggie chips plus grapes has to be at most $6.75. Chips plus grapes at most $6.75. So we need to spend less than or equal to $6.75. So here's our inequality. The first thing they do is get rid of the decimals in the numbers by multiplying every single term by 100, both sides of our inequality. So they get down to here, 100x plus 75y is less than or equal to 675. Then they continue with step 1. Step 1 is solving for y. They solve for y by getting y isolated on one side. Notice they divided by a positive number. They divided everything by 75. So the inequality symbol remained the same direction. So we get down here, y is less than or equal to 9 minus 4/3 x. So the second step down here is to graph the boundary line. We would start at 9, and we would go down 4 over 3. So again, each of these boxes on this y-axis is worth 1, and the same thing for the x-axis. So when they go down 4, they go down 4 whole grid lines. Sorry, 1, 2, 3, 4, and they go over 1, 2, 3, and they put their point. 1, 2, 3, 4, and they go over 1, 2, 3. You'll notice on this example, they are only graphing in the first quadrant. Because this is a real life example, we're going to buy either 0 packages of veggie chips or a positive number, and we're going to buy 0 grapes, bunches of grapes, or a positive number of bunches of grapes. So you'll notice that the answer, the solutions are limited to quadrant number 1. So once they graph this boundary line for step 2, and it's solid because it could equal 675, you could spend all of your money. That's solid. You need to figure out which way you're going to shade. So I would take this equation and I would say to myself, the y values less than this line. The y values below this line. So they would shade below. Or if you wanted to skip over to step 4 and plug in some numbers. Step 4 would be to plug in some numbers. I would choose a number that was obviously within, and I would choose a number that is obviously without. So this coordinate right here for me would be 1, 1. So I would plug in 1, 1. This coordinate right here would be 6, 7. So I will plug in 6, 7. So if I plug 1, 1 into my original equation, which was 100 times 1 plus 75 times 1, is that less than or equal to 6? 100 plus 75 is less than or equal to 6. Is 175 less than or equal to 675? Yes, this is true. So that means that I'm going to shade the side with that point. So again, that same little triangle. If I did 6, 7, and I started to plug it in here, I'd get 100 times 6 plus 75 times 7. 600 plus 245. So is 845 less than or equal to 675? No, that's false. So that means that all of these solutions in this part of my quadrant, this half of my plane, would not be solutions. All right, number 6, how would the graph of the solutions change if the grapes were sold for 25 cents per bunch? So this was our equation. So instead of 75 cents a bunch, it would be 25 cents a bunch. So that would move my y-intercept here, not from just 9, but it would move it all the way up, continuing up to 27. I could prove this by solving. Let me do my little solution over here. Move my 100x. That's right. Let me just double check it. 675 divided by 25. Yes, 27. So it would move my y-intercept up to 27, and it would have the slope of -4 over 1. Okay? Go ahead and try your guided practice and independent practice, and bring any questions you have to class. All right, thanks.